This is video number 2 for sections 3.5 and 11.1, solving inequalities. So take a look at this first example. We're being asked here to solve this for x. It kind of looks like an equation. And you know, when you solve an equation for x, you're just trying to find the value of x that makes the equation true. It's the same thing here. I just want to know what x can I plug in here so that this will come out true. When you solve an equation, generally you're getting one answer, but do you see here that you're going to get a whole ton of answers because whatever you plug into this left side for x, it doesn't have to come out to be perfectly equal to -1. It just has to come out less than -1. Well, I'm thinking there's lots of ways I could do that. For example, what if I picked -6 and I plugged that in for x? 3 times -6 is -18. -18 plus 5 is -13, and -13 is certainly less, it's lower than -1. So I guess x equals -6 is a solution to this equation. What about x equals -10? Well, 3 times -10 is -30, plus 5 is -25. That's what I'd get on the left. Is that less than -1? Sure, absolutely. So you can see there's lots and lots of x's that could make this thing true. Well, I don't want to sit here guessing and checking all day. You know, I want to know how can I find them all in a systematic way. And so what we really need to figure out is, do all the same tricks that we use for solving equations, do all of those work for these inequalities? Can I do those normal things? Well, let's test some of them out. So here's a straightforward enough inequality. 3 is less than 7. I'm sure you would agree with that. What if I added 2 to both sides? Can I legally do that? Does that still result in a true statement? That would make this 5 is less than 9. Well, that's still true. So it looks like that's no problem. Okay, what if I took that and I multiplied both sides by the same number? So I took, say, times 2 times 2. That would give me 6 here and 14 here. That's still true. 6 is less than 14. So apparently that trick works. So far so good, right? I mean, it kind of looks like we're safe. But watch this. So here's that same starting inequality. Look what happens if instead of multiplying by a positive number, I multiply by a negative number. What if I multiply both sides by -3? Then this would say -9 is less than -21. Hold on, that's not true. On a number line, -9 is not to the left of -21. This is not correct. The only way that I could make it correct would be to flip around the direction of the inequality symbol. This is certainly true. -9 is bigger than -21. Well, we have just discovered the one thing that is different in solving inequalities versus solving equations. The answer to the question is, do our regular algebra tricks work? Yes, but if you multiply or divide, it's the same problem. If you multiply or divide both sides by a negative, you have to flip around the direction of the inequality symbol in order for the statement to remain true. So again, the key words in this are by a negative. If you multiply or divide by a positive, that's fine. We tried that up here. But when you multiply or divide by a negative, you've got to flip around, you've got to reverse the direction of that inequality. So let's take this now and apply it back to our starting problem here. So we were given this inequality. We want to solve for x. We found a couple of solutions over here. We want to find all the solutions. So let's try to do that. Well, you just pretend this is an equation. You just do your regular solving steps with the exception of that one thing we found. So of course, what am I going to do? I'm going to subtract 5 from both sides. Subtraction is just fine. No flipping of the symbol necessary when you do subtraction. The only time to be concerned is when you start multiplying and dividing. Like here I am dividing. Is this a time where I need to flip around the inequality symbol? No, I'm fine because I just divided by a positive number. 3 is positive. No problem. So this just stays x is less than negative 2. This, by the way, is the solution to the problem. We were looking for, hey, what x could I plug in here that would make a true statement? And we're saying, you know what? If you pick any number that's lower than negative 2, remember we had negative 6 and negative 10. If you pick any number like that, you're going to make a true statement. That's the answer to the problem. When you're doing the homework, they may ask you to draw a number line picture of the answer as well. We've practiced that already. I would draw some scale and make a number line, and then I would be coloring in all numbers below negative 2. There's no equals, so I would use an open circle. I'm not including the negative 2. And then I would shade everything to the left, everything lower than negative 2. So there would be a number line picture. Or they might ask you to do an interval notation answer. Well, that's where you look at the number farthest to the left. Of course, this arrow means it goes on forever. Since it's going on forever to the left, we call that negative infinity. So negative infinity all the way to the left, comma, what's the farthest red number to the right? It's negative 2. Infinity always gets a parentheses. Numbers only get a bracket if we're including the end. We're not including negative 2. And so we just use a parentheses. There would be the interval notation way of expressing the answer. Okay, now that we've got the basic idea, let's try another example. This example looks a little bit more complicated. All of these are going to work in a similar manner. You just pretend that this is an equal sign. You do exactly the same steps that you would otherwise do, unless you are multiplying or dividing by a negative. Let's see, where should I start? I think the first thing that strikes me on this problem is that parentheses is not helping me very much, so I think I will distribute the 3 to both parts. And then the next thing that I'm not really excited about is this fraction here. I think it's always nice to clear the fractions when you're solving an equation, or in this case an inequality. The LCD is definitely a 2, and so I would have to go through and multiply both sides by 2, or another way to say that is multiply each term by 2. So I see 2 terms on the left, and I see 2 terms on the right. They all need to be multiplied by 2. Now, anytime you're multiplying, you got to think about your exception, but 2 is positive, so I'm safe, no problem there. Here the fractions cancel. I'm left just with x. 1 times 2 is 2. And then on this side, I'm going to get 6x plus 6. Okay, and then I'm going to continue solving. It looks like I need to move some terms around now using subtraction or addition. One thing I will say is this. You know how with equations you really have the choice whether you could put the x's on the left or whether you could put the x's on the right? When you're doing an inequality, I would strongly advise you to always put your x's on the left. It's not that it's impossible to put them on the right, it's just more difficult to read from right to left when you're dealing with an inequality. So I think you will have more success if you always keep your x's on the left, which of course means I'll have to move this 2 over to the right. And then let's see what that gives me. So I've got negative 5x here, and on the right side I've got 8. So we're almost done. Obviously divide both sides by negative 5, and I'm all finished. And you know, it's very easy to miss this, but here is the first time in this problem where my exception comes into play. I just divided both sides by a negative number. Well, the only way this statement remains true then is if I flip around the direction of the inequality symbol. So less than or equal turns into greater than or equal. 5 does not go in evenly, and so this is as good as I've got. X is bigger than or equal to negative 8/5. What if I want to write this in the other 2 ways? Like what if I want to draw a number line picture of my answer? Now, the 8/5 is not very helpful. I'd probably want to either grab my calculator and get a decimal from that. Negative 8/5 on the calculator turns out to be negative 1.6, or I could change it to a mixed number. So 5 goes into 8 once with 3 left over. So 8/5 is the same as 1 3/5. Probably one of these two things is helpful because that tells me, okay, I need to go between -1 and -2. I think the decimal is probably the most helpful. And let's see, negative 1.5 would be exactly halfway, so negative 1.6 is a little bit past the halfway point, so somewhere like right here. I'm going to go ahead and I'm going to put the closed circle because I can tell from my answer that I want to include the negative 8/5, and then I'm going to shade everything above. So negative 8/5 and higher is what we got. The interval notation way of writing this would be negative 8/5 is the number farthest to the left, comma, infinity to the right, bracket around the negative 8/5 because it's included, and infinity is not a number, it always gets a parentheses. Okay, let's try one more example. This final example is a little bit different looking. This one is called a compound inequality because if you look at it, you can see there are actually two less thans. Now wait a minute. Something in the middle of two less thans? We've seen that before. You know what this is? It's a between inequality. In fact, you could even read this. Would you try to figure out when 3x plus 1 comes out between negative 5 and 13? I just want to know what x's will make that happen. Well, the great thing here is you can solve one of these in the same way we were solving the other ones. You just have to do the same step to all three sides, so to speak. So think of it as an equation with three sides, even though that sounds kind of funny. As long as you do the same step, the same algebra step to all three parts, all three sides, you're legal. So remember, the goal is just to get the x by itself. So I'm concentrated here on the middle. Well, what would I do? In some ways, it's even helpful if you're really kind of stumped. If you cross out this part with your finger, then it should be pretty obvious to you what the solving step would be. Clearly, it would be subtract 1 from both sides. We're just saying you're going to do that to all three parts. So subtract 1 here, subtract 1 here, subtract 1 here. What's that going to give me? Negative 6. The middle part is really what I'm focused on. That's now 3x. And of course, this part over here is 12. What would be my next step to get the x by itself? Well, I'm going to have to divide everybody by 3. Again, as long as you're going to all three sides, you're going to get the right answer. And you know, I think I'm done. Here then is the final statement. X is now by itself. It's an x surrounded by two less thans. That is literally between. This says x is between negative 2 and 4. Apparently, if you pick any x between negative 2 and positive 4 and you stick it up in this original statement, you will get a true statement. Let's wrap up by writing this in each of the other two ways. The number line picture is pretty straightforward. I'm not going to have any arrows on this one because I'm only coloring in numbers that are in between negative 2 and 4. I do have the equals sign, so I'm including the negative 2 and the 4. Remember, this equals corresponds to these closed circles. And then I'm coloring everything in between. So here would be the number line picture. The interval notation would simply be number farthest to the left, comma, number farthest to the right. And then what do I want around them? Well, they're both included, so that's the bracket. The bracket also goes with the equals sign in the inequality symbol. This would mean all numbers from negative 2 to 4, including the ends.